In this video, we are going to evaluate the integral of sine inverse of x dx. So just by looking at this, we don't see any u-substitution we can do. So let's try integration by parts. Integration by parts tells us that the integral of u dv equals uv minus the integral of v du. So one way you can remember this as uv vdu. uv minus integral of v du. So first we need to choose u and dv. Well, there's only one thing we can really choose, so we'll let u equal sine inverse of x dx, and then dv is equal to dx. So dv can be used to solve for v. We just take the antiderivative of both sides, so v is just x. Now for u, we need to use that to compute du, so we're taking the derivative of sine inverse of x dx. Now recall that the derivative of sine inverse of x is equal to the derivative of x over the square root of 1 minus x squared. The derivative of x is just 1, so this is 1 over the square root of 1 minus x squared, and there should be dx's here. Great, so du is going to equal 1 over the square root of 1 minus x squared dx. Okay, now I can use u dv, du, and v to set up my integration by parts. So the integral of sine inverse of x dx, where this is u and this is dv, is equal to u, which is sine inverse of x, times v, which is x, minus the integral of v, which is x, times du, which is 1 over the square root of 1 minus x squared dx. So now we have another tricky integral to evaluate. For this one, we're going to want to use a u-substitution. So let's set up our u-sub. Here we want to let u equal 1 minus x squared. Then du becomes minus 2x dx, and if we want to isolate dx on one side, we can write this as du over minus 2x equals dx. So why did I choose u to be 1 minus x squared? Well, I see that I have an x that's going to be in the numerator, and it's over the square root of 1 minus x squared. So if I let u equal 1 minus x squared, then in the derivative, I'm going to have an x term where the power is 1. So hopefully there'll be some cancellation. Now let's see what happens. So this, just to simplify a bit, is x sine inverse of x minus the integral of x over the square root of u times dx, which is du over minus 2x. And so like we expected, the x's cancel out. And I have a 1 over minus 2 times du, so I can take that constant out. So what I have here is x times sine inverse of x minus 1/2 times the integral of 1 over the square root of u du. Now I can do some simplifying. This is x sine inverse of x plus 1/2. And now I have the integral of 1 over the square root of u. So I can rewrite the square root of u as u to the 1/2. And now we have 1 over the square root of u, so this is the same as u to the minus 1/2. So this is u to the minus 1/2 du, which is great because we know how to take the antiderivative of that. So this is x sine inverse of x plus 1/2 times u to the 1/2 divided by 1/2, which is just times 2. And we have our plus c. Now we can simplify this a little bit. So it's x sine inverse of x, distributing the 1/2. So this is just plus u to the 1/2 plus c. And now we have to substitute what u was. So if we scroll back up, we see that u is 1 minus x squared. So this is x sine inverse of x plus 1 minus x squared to the 1/2 plus c. And if you want, writing something to the 1/2 power is the same as taking the square root. So you can also write this as x sine inverse of x plus the square root of 1 minus x squared plus c. And that is our final answer. If this was helpful, please like and subscribe. And if there are any problems you'd like to see solved, feel free to email them to ashmath1729@gmail.com.